Right now, above your head, there are 2 trillion galaxies. Not 2 trillion stars, 2 trillion entire galaxies, each one packed with hundreds of billions of suns, each sun a nuclear furnace burning at millions of degrees. Do the math, and it should be impossible for the night sky to ever go dark. Every single line of sight in every direction should eventually crash into the surface of a star. By simple math, every square inch of the night sky should be on fire. So tell me right now, why is it dark? Why, when you step outside tonight and look up, do you see mostly black? This single question nearly broke the minds of history's greatest astronomers, and it still has no easy answer. It's called Olbers Paradox, and the answer will force you to rethink everything you think you know about space, time, and light itself. In 1823, German astronomer Heinrich Olbers formalized a question that had haunted thinkers for over a century. Picture an infinite forest. No matter which direction you look, your line of sight eventually hits a tree trunk. Now replace trees with stars. In an infinite static universe evenly filled with stars, every line of sight from Earth should eventually land on the surface of a star. The night sky shouldn't have gaps. It should be a solid sheet of fire, as bright as the surface of the sun itself. And yet we live in darkness. Something in that logic is broken. For centuries, nobody could say exactly what. The first clue lies in something so obvious we forget it entirely. Light isn't instant. It travels at 299,792 kilometers per second, impossibly fast, but not infinite. When you look at the sun, you see it as it was 8 minutes ago. When you look at the Andromeda galaxy, you're seeing light that left it 2.5 million years before humans existed. Every glance into the night sky is a glance into the past, a cosmic time machine built from photons. And here's the twist: the universe itself is not eternal, it has a birthday. Roughly 13.8 billion years ago, everything came into existence in the Big Bang. That means there is a hard horizon, a boundary, beyond which no light has had time to reach us yet, no matter how vast the universe truly is. This is the observable universe, a bubble roughly 93 billion light-years across centered on us, containing only the light that has had time to complete its journey. Beyond that bubble, there could be infinite more galaxies, infinite more stars, endlessly repeating forever. We will never see them, not because they don't exist, but because their light hasn't arrived yet, and in some cases never will. So the darkness above you isn't empty, it's incomplete. You are staring into a universe still being illuminated, one photon at a time across billions of years. Here's a question worth sitting with, slowly. If the universe is infinite, does something only become real to us once its light finally arrives? Or was it always real, simply waiting? But there's a second, even stranger piece to this puzzle, and it's where the story escalates. Even for the light that is reaching us, the universe is actively working to dim it. Space itself is expanding, and that expansion is accelerating. As galaxies race away from us, the light they emit gets stretched. Its wavelength lengthens, shifting from blue toward red, a phenomenon called redshift. Stretched light carries less energy. Visible light shifts into infrared, then microwave, then radio, invisible to the naked eye. The most extreme example is staring at you right now, filling every corner of the sky. The cosmic microwave background, the afterglow of the Big Bang itself, once blindingly hot plasma, now stretched by 13.8 billion years of expansion into a cold whisper of radio noise just 2.7 degrees above absolute zero. That's the twist that changes everything. The sky was once a wall of blinding light, just as Olbers predicted. In the universe's infancy, it was a solid, searing sheet of radiation. But cosmic expansion stretched that unbearable brightness into a wavelength our eyes can't perceive. The blazing sky didn't disappear. It went dark to us specifically, dimmed by the very fabric of space stretching over eons. We are, in a very real sense, blind to our own universe's true brightness. Evolution simply never equipped our eyes to see it. So when you look up tonight, understand what you're really witnessing. A universe still in the process of revealing itself, its oldest light, hidden in frequencies you cannot see, its farthest galaxies not yet visible because their light hasn't had time to arrive. The darkness between the stars isn't absence, it's patience. It's the universe, quite literally, still being born in front of your eyes, one photon, one light year, one heartbeat at a time. The real question was never why space is dark. It's what the sky will look like 100 billion years from now, when light we've never seen finally reaches home, illuminating a sky none of us will ever live to witness.